We will begin starting section 1.6. Section 1.6 involves looking at limits which are either going to infinity or as x goes to infinity. So the idea is that the input can continually get bigger or the output can continually get bigger. So when we deal with limits, we saw the input approach a certain number. We saw the output approach a certain number. If one of those things doesn't approach a certain number, but just keeps getting bigger and bigger and bigger, then we approach infinity. So that's the idea. When either the x value or the y value continually gets bigger, then we say it approaches infinity. Let's take a look at an example. Find the following using a graphical and a numerical approach. We're asked to find the limit as x goes to 3 from the right and the limit as x goes to 3 from the left of the expression 4 over x minus 3. Let's do this graphically and numerically. I'll start with the numerical approach. I hope you recall how to do the numerical approach. If not, go refresh on that from a previous section. So I am going to insert a table, and as my x value approaches 3 from the right, so I'm going to use x values which are above 3. My x values are going to be 3.1, 3.01, 3.001, and then 3.0001. Plug those into my function. So I plug those into the expression 4 over x minus 3. When I plug in 3.1, the output is 40. When I plug in 3.01, the output is 400. When I plug in 3.001, the output is 4,000. When I plug in 3.0001, the output is 40,000. So as you can see, as we get closer and closer to 3, our output values are getting bigger and bigger and bigger. Moreover, these are all positive. So what we say is that limit as x approaches 3 from the right of the expression 4 over x minus 3 is equal to infinity. I'm sure most of you have seen the symbol for infinity before. It looks like an 8 on its side. So symbolically, we write infinity that way. Let's take a look at the numerical approach as we approach 3 from underneath or from the left. So we're going to find the limit as we approach 3 from underneath. From underneath, I will use values of 2.9, 2.99, 2.999, 2.9999. When I plug those in to this expression, 4 over x minus 3, I end up with output values of, well, when I plug in 2.9, I end up with an output value of 40, negative 40. When I plug in 2.99, I end up with an output value of negative 400. 2.999, I get an output value that's negative 4,000. 2.999, I get an output value of negative 40,000. So as our X values are approaching 3 from the left-hand side or from underneath, these numbers on the outputs just keep getting bigger and bigger and bigger in absolute value. But because they have a negative sign in front, they're actually getting smaller and smaller and smaller in real values. So in absolute value, they're getting bigger and bigger and bigger, but we're moving on a number line towards smaller and smaller values. What we say with this is that as we approached 3 from underneath, our limit is becoming negative infinity. So negative infinity means that the values are getting bigger in terms of absolute value. So they're always getting further away from 0, but in the negative direction. Graphically, when you graph this out, create the function y equals 4 over x minus 3, you get this graph. And if you scroll out enough, you can see that this graph, as you approach from the right, this graph shoots off to infinity. As you approach from the left, this graph shoots off to negative infinity. And if we're careful about where that shoots off, you end up, whoops, no, why? Seeing that it's shooting off towards positive infinity and negative infinity right at the x value of 3. So we shoot off towards infinity as our x value becomes 3. And eventually these things, they never actually hit, but they kind of look like they hit once we get further, far enough along. Okay, so it looks like the 2 lines are right on top of each other, or the 2 curves are right on top of each other. But if you zoom in a little enough, there's always a little space in between them, as long as you zoom in far enough. So just so that you know, we have this vertical line of x equals 3. Our function approaches that from the right, it goes off towards infinity. From the left, it goes towards negative infinity. That confirms what we got here numerically. So you can see numerically, limit as we approach 3 from underneath went to negative infinity. Limit as we approach 3 from above went to positive infinity.